This is Ken and Barbie. What a lot of people don't realize is that Ken and Barbie are actually huge adrenaline junkies. They're thrill seekers, and there's nothing they like more than bungee jumping. And they've asked our class to design them the ultimate bungee jump. So, here's what we did. First of all, we have to figure out how much Barbie weighs. She doesn't like this part, but it's helpful in figuring out just exactly how much kinetic energy she's going to create as she plummets towards the ground. So here we go. Ken seems to think that she weighs about 130 grams. We'll find out. 130, and a little more. Apparently Barbie's been putting on the weight. Oh, nothing yet. Let's see here. Well, we seem to have balanced at right around 136 grams. Excellent. Next, we're going to take some weights and put the same amount of weights that Barbie weighs up onto the scale. And that's pretty close. Now that we know how many washers it takes to equal her weight, we can tie a rubber band around those washers and we can test how far they stretch. We do that by simply dropping them and measuring how far they go. That was a little fast. We're going to have to slow this down. Looks like it fell about 38 centimeters. But to be sure, we would test this 5 or 6 more times and then take an average. So once we've tested lots of different lengths of rubber bands, you start to see how this pattern works out. Every time we add a rubber band, it stretches about 30 centimeters further. So apparently, every rubber band gives me 30 centimeters. Now all we got to do is figure out how far is the drop. Here we are at the top of the stairs, and Barbie is going to jump off that. So that's a distance of 520 centimeters. Now we just got to figure out how many rubber bands do we need to make sure she gets as close as possible but doesn't hit. So then, if one rubber band gives us 30 centimeters and the entire drop is 520 centimeters, then all we have to do is go 520 centimeters divided by 30 centimeters, and that will give us our answer of 17.3 rubber bands. But there's a problem. If we attach 17 rubber bands, she will stretch all the way down to about 510 centimeters. But 510 centimeters means that her feet won't hit the ground, but the rest of her will. Not what we're looking for. We've got to figure out how tall she is and subtract that from the length. It looks like Barbie is about 30 centimeters. One rubber band. So if we take off one more rubber band, she should get close and not quite hit. So we have calculated the number of rubber bands we need. Barbie and Ken are ready to go. Ken is not going to go this time. He's just here for support. So what we're going to do is attach her rubber band to the post. Let the rest of it dangle off the edge. Oops. It looks like Barbie's ready. Bye-bye now. Looks like just another great day for Barbie and Ken. So the only question left to ask is, did Ken jump? Well, the answer is yes, he did. He used the same calculations, 16 rubber bands, and this is what happened. But why? Why did Ken have such a hard time? The answer comes in the form of kinetic energy, which is half the mass times the speed squared. Barbie and Ken were going the same speed as they fell. But Ken weighed more than Barbie, which meant that he had more kinetic energy and he stretched those 16 rubber bands even further. And so everybody has to be calculated differently based on their weight. Let's see how some of Barbie's friends did.